In last class, we saw what is photoelectric effect, and today we will see about the application of photoelectric effect. So we will talk about two application. One is in solar cells, and the other one is in photo multiplier tubes. Okay, so let's see about solar cells. Okay, so solar panels are basically semiconductor materials. Okay, so here photoelectric effect happens. Okay, which is the photons are absorbed, and thereby we see that current is produced. Okay, or we can say there's a flow of current. Okay, now a solar cell is made up of at least two semiconductor layers. Okay, where we have a positive layer and a negative layer. We can say that the regions are N region. This is the N region, and this is the P region. At least two layers, and there is a junction between these two. When we combine these two layers, it forms there is a formation of a junction. Okay, we can say that this is the junction. Okay, and now we see that when light, okay, and we connect this to the, we can have a small bulb. Okay, and we also connect an ammeter to see whether the current flows or not. Okay, so when the sunlight, okay, when it strikes, we see here sunlight is incident, we see that electrons and holes are created. Okay, we know that electrons, can be filled up to the valence band in the atom. Okay, and when this light, okay, so when light, okay, when light strikes on these electrons which is in the atom, okay, these electrons are in the valence band. Okay, they immediately, okay, jump to the conduction band. Okay, such that only if they have enough of energy, they jump to the conduction band. Okay, okay, and therefore in the conduction band we have free electrons. Okay, so we have free electrons, and here we have in the valence band we have holes created because the electrons have been excited. Okay, so that's what happens. Okay, so the N type contains naturally more electrons, and the P type has more holes naturally. And now, when light strikes, there's electrons and holes created. And now, what happens? The created electrons and holes, they start moving. Okay, they start moving in such a way that the holes move towards the P side, and the electron move towards the N side. And once they start moving, and we see that there is a buildup of electric field. Why? Because there is increase of oppositely charged carriers. Okay, so there is an electric field between these two NP type, but there is also a electric field in this depletion region, or we can say in the junction, which is preventing for so that it does not collapse. Okay, so these electrons, what happens, it will start flowing in the external circuit, okay, due to this electric field, and they start flowing in the external circuit, and thereby we measure a current. Okay, so the electrons move. Okay, this is a movement of electrons. Okay, and yeah, they move, and we do record a current. Okay, so this is the movement of electrons, so the arrow should be in the opposite way. Okay, so I will erase the arrow, and we will draw it this way, because this is a flow of current which is opposite to the motion of electrons. Okay, and we see that if we keep a bulb or load, a small load here, resistance, we see that it gets LED or something. And we see that it will get heated up in case of a small resistance or something, or we can say that the bulb will glow. Okay, now so the points to remember is that the electrons and holes are created. Okay, that is the number one point. And then the electron move towards the N region and the holes move towards the P region. The N region is occupied with majority of electrons and P region has majority of holes. Okay, due to the potential difference, current flows in the external circuit and thereby a bulb here glows. Okay, so thereby a bulb glows. So this is the application of the photoelectric effect in solar cells. uh, in the next video we will see about photomultipliers. Thank you.